Binary logistic regression with ordinal predictor in JAMOVI. Binary logistic regression is a statistical test that can be used or performed when there are two variables. One of the variable, which is the outcome, or it can be called the response or the dependent variable, and the other variable is called predictor or explanatory or exposure or independent variable. The aim of this test to find out whether and to test whether there is a relationship between the predictor and the outcome. For doing binary logistic regression, the outcome have to be binary. The variable have to be binary, which means it have to have two levels in it, such as you do have diabetes, no diabetes, have cancer, no cancer. For the predictor, it can be continuous, which is measured at a interval or ratio scale, or it can be binary, which has two levels in it, such as the sex or gender, or it can be multinomial, which has three or more levels in it, such as occupation, and it can be ordinal variable. Ordinal variable is categorical variable, a variable with multiple categories in it. The ordinal predictor or ordinal variables have categories with order in it, such as the age classes. Age classes are categories, but they have order, the youngest to the oldest. So the binary logistic regression can be used to find out whether there is association or relationship between predictor and outcome, and whether the predictor can explain the variation in the outcome. Here in JAMOVI data sheet, I had inserted 200 cases, and there are two variables. The first one is the age category, the second one is diabetes. So the diabetes is a binary variable because it has only two levels in it, whether you have diabetes or no diabetes. Age, though age is continuous, but here it is classes or categories. Category from 16 years old to 24, and then the second category is from 25 to 45. The third one is from 46 to 70, and the fourth one is greater than 70 years old. So there are four categories here, youngest one to the oldest one, though it is age, but it is in category and there is order in it, youngest, older. So this is a ordinal variable. It is categorical, but it is ordinal, more precisely ordinal, as it has order in it. So to find out whether there is association or relationship between the age category and the diabetes, and whether this predictor, which is the age category, can predict possibility of getting diabetes, or the outcome, which is diabetes, variation in it can be explained by the age categories, then binary logistic regression can be used, as the outcome here, which is diabetes, is binary and the predictor is ordinal. Before we proceed to the regression, let's look at some descriptive statistics. Click on exploration and then select descriptive, then drag the age category into the variables, the diabetes into the variables, tick on the frequency tables. Let's get rid of, since both of them are categories, we don't need the mean and the median. We remove the standard deviation, we keep the minimum and the maximum. From the output for the descriptive analysis, there are 200 cases. So both variable, there are 200 cases and no missing cases as shown here. The age category is assigned values 0, 1, 2, 3. The 0 assigned for the age category from 16 to 24. The value 1 assigned for 25 to 45, and value 2 assigned for 46 to 70, and 3 for anything greater than 70 years old. The second table shows the frequencies in each category. So as we have 4 categories here, there are 50 individual or cases in each category. For the binary outcome, which is a diabetes, there are 81 cases of those who have diabetes and 119 without diabetes. So those who do not have diabetes have a higher proportion. To do binary logistic regression, click on regression, scroll down to the 2 outcome binomial. Since this these data fit perfectly to the binary logistic regression. In this window, diabetes is our outcome, so we'll move it to the dependent variable. And since the age categories is factors, we'll keep it into the factors. We could move it to covariate, but we'll keep it here into the factors, and the age category is best fit here. Let's select some of the options here. We'll click on the reference levels. Since we have here 2 variables, both of them have categories in it. The diabetes have either you have diabetes or yes or no. No will be used as a reference category to compare to. Age category, which is from 16 to 24 years old, will be used as a reference category to compare to. Moving to the, I'm going to skip the assumption checks. Moving to the model fit, tick on the Cox and Snell's R Square and the other R Squares. For model coefficient, I'm going to tick on the odds ratio and the 95% confidence interval. For estimated margin, no selection. For prediction, no selection at this stage. Looking at the output here, we have 2 important tables. The first table is for model fit measures. Looking at the R square here, it shows that a value of 0.255. This value means that 25.5% of the variation in the outcome, which is diabetes, can be explained by the predictor, which is the age categories. Moving to the second table, which is the model coefficient for diabetes, we used those who with no diabetes group as a reference group. And for a predictor, which is the age categories, all the 3 are compared to the reference category, which is 16 to 24. So this is the reference category here. In the table, we're going to ignore the intercept, and looking at the footnote here, it says that the odds of diabetes for yes and no. Values here is estimate for the coefficient, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval. So there are 2 levels here for checking significance. P-value, any p-value less than 0.05 will be considered as significant, and 95% confidence interval, when the odds ratio fit between the upper and lower limit, then it is significant. So here from this output, we can see that there is a significant association between diabetes and the predictor, and even with each categories of the predictor. So there is association. The outcome, variation in the outcome in diabetes can be explained by the age category. So age is a factor that can explain whether you will have a chance, probability, likelihood to get diabetes. The way to interpret this table is that looking at the first category, for those individuals who are in the age range of 25 to 45 years old, have an increased 3.1 odds of having or developing diabetes compared to the younger generation, which is, or younger individual, 16 to 24. So older individuals have a higher chances or are more likely to develop diabetes than younger one. For the second category, which is from 46 to 70 years old, those individuals in that category have an increased 7.3 odds of developing diabetes compared to the younger group. So with increased age category, the odds increases. So that means the elder people have a higher likely chance of developing diabetes. Looking at the final category here, those who greater than 70 have the highest likely or chances of developing diabetes compared to the younger group from 16 to 24. And all these findings are significant. So this is the way to perform binary logistic regression with an ordinal predictor in JAMOVI. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.